This is MAT 175, Lesson 23, Section 6.1, Angles and their Measures. Here we have a ray where we have an endpoint and it continues on indefinitely versus a line that has two arrows, or it continues on indefinitely in both directions. So ray would be considered a line that has an endpoint on it. Whereas here we have a vertex that is the endpoint of two rays. And we have an angle alpha, Greek letter alpha, where we have the initial side where we start from, and then the angle ends up on what's called the terminal side. And positive angles go in a counterclockwise direction around the unit circle, and so the angle is positive. A negative angle will go in a clockwise direction, and it will always start from the initial side and end up on the terminal side. And here we have an angle that goes a full 360 degrees and then stops at the terminal side. And so we can have one angle that is coterminal to angles that are going in the opposite direction, clockwise, or it can go counterclockwise, but then it does a full 360 degrees and then ends up on the angle. So if this was 30, then this would be 360 plus 30 would be 390, and so on. And those angles are all coterminal with 30. And this one here, this would be a negative 330 degrees. And that would also be coterminal with 30 degrees, because they have the same initial and terminal side, but in different directions. And theta is in standard position, and theta is positive. So here we have the XY coordinate plane. Again, the initial side is always on the positive x-axis. Vertex is at the origin, and then the terminal side, that's where the angle ends. So this would be angle theta. Here, again, the initial side is on the x-axis. Vertex is at the origin, but now the angle is a negative, and it ends at, again, the terminal side. And we have, in this case, theta, it lies in quadrant 2. Here it's in quadrant 4. And so when we have theta ending up on a either an x or y axis, it's a quadrantial angle. So if we look at our quadrants on our unit circle, we can see that, get this up, we have quadrant 1, quadrant 2, quadrant 3, and quadrant 4. And depending on, again, the angle always starts at positive x-axis, and depending on where the terminal side ends up is going to depend on where what quadrant that angle ends up in. Here we have an angle that does a full 360 degrees and has both the terminal and the initial side is all the same line. And we would say that this was one revolution, and that was counterclockwise. 90-degree angle, you always see this perpendicular box looking figure here. We have the initial side and the terminal side. And this would be a quarter revolution around, that goes completely around the coordinate plane. Anytime you see a straight line, you can imagine a vertex in the middle, and that's a full 180. This would be 180 degrees here. So any straight line would be considered 180 degrees. Okay, we want to draw each angle 45 degrees. That's going to be in the first quadrant. A negative 90 degrees, that's going to go in a clockwise direction. And starting from the initial side, it goes in a clockwise direction. So you could say that that is coterminal with, if you were to go, your angle was positive, 270 degrees. And then here's 225 degrees. Well, one way to look at this is this is from here to here, that's 180 degrees, and this is 270 over here. Go all the way around to this. So 225 is going to be in between 180 and 270, so that would put us in quadrant 3. And then 405 degrees, it does a full 360 and then continues on through that to give you more than one revolution. Okay, we're going to convert between decimals and degrees, minutes and seconds, measures of our angles. We have here 1 degree equals to 60 minutes. So if we were to look at, let's say we have here's 1, let's say that this is 1 degree right here. Now if we took that and we blew that up, you would see here I didn't draw 60 minutes, but you could see that 1 degree would have 60 minutes, and each one of these hash marks would be a minute. Now if we were to take if we were to examine 1 minute and blow that up, then from there we would see that would have 60 more hash marks in it, and that would be 60 seconds. And so we can say from here that we wanted to convert from 12 minutes 5 seconds to a decimal in degrees. What we could do is we could look at 1 degree is equal to 60 minutes. So we want, if we had here 40 degrees, 12 minutes, and 5 seconds, well, what we would do here is we would put plus and then 5 seconds here. We could ask ourselves, 1 degree is equal to 60 minutes. So we could write it as 1 degree over 60 minutes like that, or 60 minutes over 1 degree, depending on what it was you're trying to convert. So here we want to go from minutes to degrees. So if minutes is up here at the top, we can look at this as 12 minutes over 1. Then we would want the 60 minutes on the bottom and 1 degree on the top, like that. So we're actually going to divide 60 minutes into 12. And we could look at this as the minute units cancel, and we're going to end up with degrees. Now here, because we have 1 degree equals to 60 minutes, and then 1 minute equals to 60 seconds, we can also say that 1 degree equals to, since 6 times 6 is 36, 60 times 60 is 3600 seconds. So we could also write this as, so we would ask ourselves, are we going to write this as 1 degree over 3600 seconds, or 3600 seconds over 1 degree? Well, because the seconds unit is in the numerator, we're going to want the 3600 seconds in the denominator and 1 degree, because that's what we want to end up with. So we're always going to put in the denominator whatever we're going to cancel in the numerator on the other side. So from here, you can see that you're going to get here, they use 1 over 60 times 1 over 60. We use 1 over 3600. So as a decimal, we're going to end up with 40.2014 degrees. So we've converted from degrees, minutes, and seconds to just strictly degrees. Here we want to convert from 78.562 degrees. We want to convert that to degrees, minutes, and seconds. So now what we're going to do is we're going to take 78.562 degrees, and now we're going to multiply that. We want to come up with the minutes first. So we want to ask ourselves, are we going to put, what are we going to put in the denominator so that we can cancel this degree units out? We're going to put the 1 degree or the 60 minutes. You should have answered, we're going to put the 1 degree in the denominator and the 60 minutes in the numerator so that the degree units cancel, and now we know that we're going to multiply 60 minutes into our problem. And so when we do that, we're going to get, from there we're going to get 33.72. So this is going to be 78 plus 33.72. And so from there we have minutes, but now we don't want just minutes, we want minutes and seconds. If we wanted minutes left over, degrees and minutes, then we could stop here. But we don't. We want minutes and seconds. So we're going to do the same thing. Well, we know that 1 minute equals to 60 seconds. So we are going to multiply here. Are we going to multiply 1 minute over 60 seconds? Or 60 seconds over 1 minute? Well, you look at, what we're going to cancel and what has to go in the denominator cancel with this minute units. So you should have said that you're going to cancel, you're going to put the 1 minute in the denominator and the 60 seconds in the numerator so that the minute units cancel out. And so we're going to multiply 60 seconds into that. And so when we do that, we're going to get 78 degrees, 33 minutes, and 43 seconds. And since this is comes out to be 43.2 seconds, we just go ahead and round it off to 78 degrees, 33 minutes, 43 seconds. Okay, now we're going to take a look at radians. Now, one way to look at this is here we have from 0, if we look at this, here's 90, and we know this is 180, and this is 270 degrees. Well, we know that from 0 to 180, that's 1 pi. And so if we kept going on around, that would be 2 pi. And pi is the ratio of a circle between the circumference of a circle and its diameter. So, but we just always just refer to this is just just as pi. So 1 radian is basically we're looking at the conversion between degrees and radians. So again, we have our initial side and we have our terminal side. And so our angle now, instead of in degrees, it's in radians. So we know that 1 revolution equals to 2 pi radians. So if we're looking at like the wheel of a bicycle, and we were to go forward and the wheel were to make 1 complete turn, that would be 1 revolution. And so we could say that we have this circumference around the circle. So since 1 revolution is 2 pi radians, we know that 1 revolution is 360 degrees. Well, if we divide both sides by 2, then we have 1 pi is 180 degrees. So we use this as a conversion to convert from degrees to radians. And so radian is the ratio between pi and 180. And so from there, if we want to convert, let's say 30 degrees to from degrees to radians, we would take 30 degrees, and we know that 1 pi radian equals to 180 degrees. So we ask ourselves, are we going to use pi radians over 180 degrees, or are we going to use 180 degrees over pi radians? Now, if it doesn't have the degree symbol in it, then it's in radians. Okay, well, these are all in degrees, so we're going to convert this from degrees to radians. So we need to know what will cancel this degree units out. Well, it would have to be the first one, because we want the 180 in the degrees in the denominator, so we can cancel the degree units out. And so the degree units can cancel, and now we can just go ahead and convert it from there. And that's what we did here. And so, 30 goes into 180, and that's 6, so we end up with pi over 6 radians. So if we were to look at this on the unit circle, let's back up here for a minute. If we were to look at this on the unit circle, here's pi. Here's pi over 6 radians. We could say, radians. We could say that this is 1/6 of pi. And so, so if this was 60 degrees, then it would be pi over 3, and that would be 1/3. So let's take a look at that. So B, again, we're going to cancel, the degree radians. We're going to have pi radians over 180. We get 2/3 pi radians. So if we were to look at this on the unit circle, here's going to be 120. Here's 90. Here's 180 degrees. So 120 is going to be in between 90 and 180, right? Well, that's also, so this is 120 degrees, but it's also 2 pi over 3 radians. And we could look at this as 2/3 of pi. So it's a fraction of pi. Alright, and so the next one, negative 60 degrees, well, that's going to go in the clockwise direction. And so you would take the negative pi radians over 60, and so that would be 16 to 80, and that'd be 3 here. And so that the negative carries over and be negative pi radians. So it'd be like 1/3 of a pi, but it's going in the negative direction. So the negative tells you which direction, a negative or positive is telling you which direction the angle is going in. Positive, it's going counterclockwise. Negative, the angle is going clockwise. And here's 270, and that's gone. If you were to look at the unit circle again, here's 90, 180, 270, 360. Here it's going 1.5 of pi. So complete circle, that would be 2 pi radians. But we've gone 3/2 that, or 1.5 radians. Okay, and 104 degrees, that would be one. Here we're going to end up with a decimal. Alright, now we're going to convert the angle from radians to degrees. So here we have pi over 3 radians. Now the radians, you can always put that with the pi. Now let's say it didn't have radians. Let's just say it had, well, just pi. Well, then that would still be, there's no degree there, so it'd still be considered radians. So now at this point, again, we're going to ask ourselves, here's 180 degrees equals 2 pi radians. And so this time, the pi is in the numerator, so we need the radians. Pi radians is the numerator, so we want the radians to cancel. So we want the pi radians in the denominator. And so that would be 180 in the numerator, degrees. And so the radian units cancels. In this case, the pi also cancels. And so we know that 3 can go into 180, and that's going to be 60 degrees. And so that's our answer. And so here, negative pi over 2 radians, again, we're going to put 180 over pi, and we're going to get a negative 90. And here's 5 pi over 6, again, 180 over pi. The pi's cancel, and 6 can go in 180, and we end up with 150. 6 goes into 180, and that's 30, and so 5 times 30 is 150. Now here, let's back up for a minute. Here, sometimes they will have something like this, where, let's say there was no, it was just 5. Let's just say they just had 5 there, and that's all. Well, if there's no degree, think of it this way. If there's no degree, then automatically you're going to put radians in there. If there's no degrees, automatically it's considered radians. So in that case, is the, you look at 180 degrees equals to pi radians. So you want the radians to cancel. So are you going to put this 180 over pi radians or pi radians over 180? Well, you want the radians to cancel. So we're going to put pi radians in the denominator and 180 degrees in the numerator. And now the radians can cancel. And so the way you're going to enter this in the calculator, this would be 5 times 180 divided by pi. And so that's what they're going to, but they have the radians in there. So, and again, the radians are going to cancel out. Okay, the length of an arc on the unit circle. Okay, here, if you're looking at the unit circle, let's say that we have this circle here, and we want to examine the arc in between that is within that circle. So really what we're looking at is this arc length right here. Well, it's not flat, it's curved. So we can't use just the Pythagorean theorem. This wouldn't be like this is, a right angle here, so we can't use the Pythagorean theorem. So we have to use S equals to R theta, where S is the arc length, the curve and length, and R is the radius of our circle, and theta, that's the internal angle. Alright, so we want to find the length of the arc of a circle of radius 4 meters. So it's subtended by a central angle of 0.5 radians. Okay, so if we were to look at this within our circle, alright, now let's say this is our circle, and we have this internal angle in there. And we want to find this arc length S here. We want to find this arc length right here. Alright, we're going to use S equals to R theta. So the radius, we said that's 4 meters. And we also know that the angle is 0.5 radians. So we're just going to multiply 4 times 0.5, and we end up with just 2 meters. Because our radius is in meters, our arc length is also going to be in meters. Okay. This gives a chart, conversion chart from degrees to radians. Now, if you look on here, you can see that here's our from 0 to pi. So 90 degrees, that would be half of pi. So that's pi over 2. Well, 45 degrees, that's half of that. Well, that's going to be, since that's half of 90, then that's going to be a quarter of pi. So that's pi over 4. And so on. 60 degrees, that would be a third of pi. So if we were to look at 60 degrees, here's 60, we know that 60 is, 1/3. If we had 60 over 180, that's 1/3. So this would be 1 pi over 3 radians. And so that's, the entire conversion works that way.